My name is Sara Inani, and this is my Physics Lab 3. In this lab, we're observing a star's motion around a black hole to find the mass of the black hole. In the previous labs, we used the known forces and Newton's second law in order to predict the motion of an object, but in this lab, we're working backwards and we're using the motion and Newton's second law to predict the mass. We're using net force, momentum, and velocity. As said, we're using Newton's second law and also gravitational force, Newton's universal law of gravitational force. And here are the formulas that we're using throughout the lab. For this lab, we're using GlowScript, an online program that helps me compute animations and motions easily. Given the starter code, I entered this seed, which determines my unique trajectory. And then we're taking the gravitation constant as 6.7 into 10 to the power negative 11. The mass of the star is 2 into 10 to the power 30, and delta T is 86,400 seconds, which is equal to 24 hours. Here is the coding that I have used. Updating the code that was given to us, I used Newton's second law, P equals mv, updated the v initial and v final, calculated P initial and P final, and using dptd formula to determine Fnet. Below, we're finding the specific components, Fnet perpendicular, Fnet parallel, and dpdt perpendicular. Now, we know through Newton's universal gravitational law that force due to gravity equals gravity constant into mass 1 into mass 2 divided by the relative distance between them, where mass 1 is being taken as the mass of black hole over here. As said earlier, we're calculating it in reverse order, where we're trying to find the mass using the motion, and hence using the motion to calculate the force. So thus the formula can be rewritten like this. As you can see, I have updated this formula in my GlowScript, and below are the arrows for both components of Fnet. Here's the diagram and a specific point of the motion. The magenta arrow represents Fnet perpendicular and the cyan arrow represents Fnet parallel, and we can see a complete motion being done. At the end of the GlowScript, we can see the Fnet completely, Fnet parallel and Fnet perpendicular. I was given a list of masses that could be determined at every point, and I had to input it into a Google Doc, take the average of it. So my final mass was 1.15442 into 10 to the power 34. How does the net force and its parallel and perpendicular components are different from the rate of change of momentum and its perpendicular and parallel components? As you can see, I have written the formulas below, but let me get into more depth about that. While they may be equal in magnitude, they do have different meanings. Fnet parallel equals forces in the parallel direction. Fnet perpendicular means forces in the perpendicular direction. The rate of change of momentum parallel equals change in speed, and the rate of change of momentum perpendicular equals change in direction. So while they may be equal in values, they represent different things. Imagine the black hole whose mass you found was removed and a different black hole was placed in the same location. Assuming that the motion and the observed star remains unchanged and is affected by the gravitational force of the new black hole, could you tell the difference? Is it possible for you to find the mass of a black hole that is different from the mass of the original one? No. Since we're using the formula in the opposite direction, we're using the motion to find the force and hence the mass. So since we're implying that the motion is same, so the gravitational force is unchanged and it is equal, so the motion is unchanged, which means the gravitational force of the second black hole is equal to the gravitational force of the first black hole. And since we're using the formula, that means that the mass should be the same as well. Thank you.